right, so today we are going to start to do some practice with something called the distributive property. And we actually have been using the distributive property to do mental math all along, but we're going to do some examples with that and also how we use it with variables getting ready for algebra. So just in general, what does it mean to distribute something? It's a verb. To distribute is to spread out or to cover something. So when we're looking at math, if we have three numbers, and these are just letters that stand for numbers, these could be variables or numbers. If you have something with parentheses, two things being added inside parentheses, or more than two things, anything being added in parentheses with a number out front, when there's nothing in between a number or a letter and parentheses, it means times. So this means A times B plus C, which means if there's an A times this whole thing, we need to multiply this number by everything in the parentheses. This would be A times B plus, then you go back out here and do A times C. You have to multiply this number on the outside by everything on the inside. And that is what the distributive property is. We're distributing it to be multiplied by everything there. So we're going to show you how we use that with just mental math and with some variables. This first example says we use the distributive property often when we're multiplying large numbers mentally. And let me just give you an example. If I wanted to do, 4 times 76. Right? If I asked you to do that mentally, your head probably breaks this down into some smaller numbers to be able to do all at once, because I don't have 4 times 76 memorized. Here's what's probably going on in your head. And I'm just going to write this a little bit differently. I'm going to write it as 4 times 76 this way, because parentheses in between numbers mean the same thing as the multiplying. So this means 4 times 76. Our head breaks down 76 into 70 and 6. 70 plus 6. And when I do 4 times 76, I do 4 times 70 and 4 times 6. And when I get those two numbers, I add them together. So I do in my head 4 times 70, and then I do 4 times 6, and I bring down my plus in between them. Because mentally I can do 4 times 70. 4 times 7 is 28, so add a 0, 280. Mentally I can do 4 times 6 is 24, and mentally I could add those guys together. Let's see, that gets me just past 300, so it's 304. I would be doing this process in my head, but the process is the distributive property. 4 times 70 and 4 times 6. So we've been doing it with this kind of situation. We just haven't been writing it down this way. So let's look at how we can use it when we start to have some variables. So if I've got this situation, 4 parentheses 10 plus x. All right, I'm going to rewrite this just so I don't have anything underneath it, just so I can see this a little bit better. If I said simplify this right here, in the order of operations, we'd want to do what comes first, parentheses. Can I add these two things together in the parentheses? Can I do 10 plus x and just make that 10x? I can't, because they're not like terms. This has an x, this is just a constant with no x. I can't add them together. So I would be stuck. There's no like terms. I can't do what's in the parentheses. But there's this number 4 that's being multiplied on the outside, which shows me that this is an example of the distributive property. I can take this 4 and I can multiply it by everything that's in those parentheses, and that will simplify this expression. So 4 times 10, what is 4 times 10? 40. And what's 4 times x? I don't know what x is, so I know it's 4 times x, or I could just write that as 4x. That means 4 times x, and this plus sign stays in between them. So 4 times 10 plus x is the same thing as saying 40 plus 4 times x. It would give me the same answer if I plugged something in for x for both of them. But this is considered a simplified version of that. Essentially, we got rid of our parentheses by doing that distributive property, and so this is a simpler form. So this is the kind of thing we're going to be doing today, where we're doing this multiplication, and it's going to help us get rid of parentheses and make it simpler. So let's look at the next page, example 3. Right at the top here it says we can use the distributive property to help us simplify expressions when we might otherwise be stuck with nothing else to do. So another example of that is this one, -2 parentheses 3x plus 3. Can I add the 3x plus 3 together and make that 6x? No, because they're not like terms. This has an x, this is a constant. I can't do anything, so I would be stuck, except that there's this -2 out front, which means -2 times this whole thing. So I'm going to use my distributive property and draw my little upside down rainbows here. I'm going to do -2 times 3x, and then also -2 times 3. I've got to multiply it by everything in those parentheses to distribute it. So what is -2 times 3x? Am I allowed to multiply a constant and a term with a variable here? Yeah, because these aren't terms. They're being multiplied, not added. I can multiply anything I want. So I can do -2 times 3x. It's just -2 times 3 and still times an x. So -2 times +3. Negative times a positive is a -6, and it still times an x. So -6x. Then I go over here, -2 times just a 3, negative times a positive is a -6. And then we bring my plus down right in between them. So this turned into -6x plus -6. It's a simplified version of that expression. And this would be as simple as I could go because these are not like terms. So what did we get rid of in that expression by using the distributive property? We got rid of the parentheses. Got rid of the parentheses. So let's try this a little bit more with some other examples and things that get maybe a little step harder each time and see if we can do it. All right, let's simplify. 2 parentheses c plus 7. All right, the first thing I'm going to do is I want to change that subtraction to adding the opposite plus a -7 so that I'm always dealing with addition and I'll be able to combine like terms later if there are any. And I can't add the c plus the -7. Those are not like terms, but this looks like a distributive property to me. Anytime I see parentheses with something outside it being multiplied, I know I'm going to be able to multiply 2 times c and 2 times -7. So what is 2 times c? Just 2c, 2 times c. I'm going to bring my plus down right now so I don't forget that. And what's 2 times -7? A positive times a negative is a negative. It becomes -14. That is my simplified version. Can I add the 2c and the -14 together? Nope, they're not like terms. So that's as simplified as we can make it. Okay, let's look at this guy, number 5. So there are actually a couple of different ways to do this. Let me show you one way first, and then we'll talk about another strategy. This one, there's brackets, which, guys, are the same thing as parentheses. These could have just been parentheses right here. Parentheses and brackets do the same thing. So this time, I've got 3 things in the parentheses. Are they being added yet? Not that one, but we can change that. How do I change subtraction to adding the opposite? I make it plus a -11. So I could notice that there's a 5 outside these parentheses where things are being added, and I could do the distributive property right away. There's 3 things in the parentheses, so that means that this 5 has to be multiplied by all 3, by the b, by the -11, and by the -7. I distribute it to everything in the parentheses, no matter how many things are being added up. So let's see what this would turn out to be. 5 times b is 5b, plus, what's 5 times -11? -55, plus 5 times -7, positive times a negative is another -35. So I did the distributive property to try and simplify. And now am I done? No, because these 2 are constants. And they can be combined. They can be added because they are like terms. So now I can do a little bit more simplifying. And I just have to make sure I do my adding right. A negative plus another negative gets more negative. So this stays a negative, and 55 and 35 should be 90. So I combined those like terms, and this 5b was just sitting out there. It didn't have any like terms to combine. So here is my final simplified version of this expression. And I could always put parentheses around here just to separate the plus and the negative. That's up to you. But that would be my simplified expression for this. Another way you could have done this is, did anybody notice that I could have just added the -11 and the -7 right away, because they were like terms inside those parentheses. So if I did that, I would have had a -18 inside the parentheses. And then when I did the distributive property, it would have been 5 times b and 5 times -18, which is negative 90, but honestly, I don't have that one memorized, so I'd kind of like to use these smaller numbers when I can because I know that multiplication. Either way, you would have gotten the same answer. All right, so let's look at another couple of situations where there's not just the distributive property going on. With this one, example 6, we've got this negative n. This is a minus, even though it doesn't really look like it. It looks kind of like a negative. Minus 2 parentheses, and 9 plus n, and then plus a 3n outside of those parentheses. There's a lot going on here. The first thing I'm going to do is change this subtraction so that I don't make any mistakes with negatives. It's like adding the opposite. So I'm going to make that into a negative 2. Now, what I want to look at here is that there's some adding going on, but I am not allowed to add any like terms yet. Why wouldn't I be allowed to add things yet? Think about the order of operations. What comes before adding? Well, let's do the order of operations. Parentheses. Is there anything I can do in the parentheses? I can't do 9 plus n because they're not like terms, so I can't do parentheses. Next would be exponents. No exponents here. Then there's multiplying, dividing. Is there any multiplying or dividing here? It's kind of hidden, but yeah, this right here, when there's nothing between a number and a parentheses, means times. So that means I need to do my multiplying before I'm allowed to add any like terms. And in this case, my multiplying means that negative 2 needs to be multiplied by everything in here. It's going to be a distributive property. I've got lots of multiplying to do. Am I going to multiply negative 2 times this 3n out here? No, because when the parentheses end, that's when our distributive property ends. Do I need to multiply anything by this negative n? No, it wasn't anywhere near my distributive property. Essentially, this is the only thing I need to do to multiply right there. So I'm going to do that multiplying, and then we'll deal with these guys that are hanging out at the front and at the back. So what is negative 2 times 9? Negative times a positive is a negative 18. Plus, what's a negative 2 times n? It would just be negative 2n. That takes care of my distributive property. And now these guys that were hanging out, we just bring them down. So there was a negative n out front, there's still a negative n. There was a plus, there's still a plus. After the parentheses, there was a plus and a 3n. So I bring all those down. And at this point, now there's no parentheses left, there's no multiplying left to do, so I can just look at adding. Can I add some of these together? Yeah. All these n's are like terms. So I can add those like terms together. We're going to be careful here. A negative n is how many? It's like a negative 1. So a negative 1 plus a negative 2 takes me down to a negative 3. Negative plus a negative gets more negative. So now I'm at negative 3n's. And then plus positive 3n's. Isn't negative 3 plus positive 3 just 0? They're opposites. They cancel each other out. So I actually have no n's left once I add all these together. I could write 0n, or I could just say they're all gone. There's no n's, and all that's left in this particular one is a negative 18. That's simplified down really well. I would say negative 18 is way simpler than this guy up here. All right. So let's look at another example of when we've got more going on than just one distributive property. This one here, we've got negative 7 times these parentheses, and then we've got this minus and some more parentheses. Can we go ahead and change the subtraction to adding the opposite first? So how do I change this? I'm going to make this plus a negative. And then this one also, I'm going to make this subtraction plus a negative, but it's tricky because a negative what? We really do need a number out in front of there with that negative. So if there's no number in front of the parentheses, how many parentheses are there? There's just one. So this negative is really just like having a negative 1 right there. That negative and a negative 1 do the same thing. But when you see the number there, it kind of helps you realize that this is something that's being multiplied by the parentheses, and this is going to be a distributive property. Just like this one here. This one also has a number being multiplied out front of parentheses, so that is going to be another distributive property. So this is a problem where there were 2 parentheses. We've got 2 different distributive properties that we've got to do to simplify this. So we're going to take care of that first because that is the multiplication in this problem. We've got to multiply before we can try and combine any like terms. So let's see what we get. Negative 7 times 3y. Negative times a positive is a negative 21, and it's still times a y. And then don't forget, we also have to do negative 7 times this guy. So negative 7 times a negative 1, negative times a negative becomes a positive. And we still put that plus right in between us. Okay. Then we bring this plus down. It was still there. And we do this distributive property. Negative 1 times y is a negative 1y. Is that the same thing as just a negative y? Yeah, I'm going to leave the negative 1 there just so it helps me when I'm combining like terms, but it's the same thing as negative y. And what about negative 1 times 2? Negative times a positive becomes a negative 2, and we bring our plus sign down. So we always have pluses in between everything. Now there's no more multiplication, so I'm going to look for some like terms. Can I combine anything here? I see these are y's and these are y's. Negative 21y's plus negative 1y's. Negative plus a negative gets more negative 22y's. And then I'm also seeing that these two are constants. No variables, that means they're like terms, so I can combine those constants. 7 plus negative 2 takes you down to a positive 5. So here would be our simplified expression for this. That definitely got a lot simpler looking than all of these different things happening there. Could I also have used the commutative property and switched the order of these? Could this be 5 plus negative 22y? Sure. We can always use that commutative property if all we've got is addition. Okay, last one for now, for these practice ones, is example 8. And this one, can we just go ahead and change all the subtraction to adding the opposite first? We're going to do that on every problem first thing. This subtraction is just like saying plus a negative 7y. This subtraction is like saying plus a negative y, or you could say negative 1y for that one. Now, there's only one parenthesis here. Is there something being multiplied on the outside of it? Yep. So we are going to do a distributive property for this. And this one is just a bit trickier because there's an x on the outside. And if you look, we haven't had a variable on the outside of any of our distributive property practice yet. So in this case, there's a variable on the outside. This is 6x times x. So if I wrote that out, I'm going to do it over here. 6x times x would look like this, 6xx. But we know another way to write x times x. The simplified way to write x times x is just x squared. So x times x would become x squared. A number times itself is squared. So whenever we have something where it's a variable times another variable that's the same one, 6x times x, that becomes 6x squared. And that is a tricky part to get used to, so we'll do more practice with it. Then there's still a plus sign, and now look at what we're multiplying here. 6x times negative 7y. So we're doing an x times a y, which is okay. We don't have to have like terms. This is multiplying. We can multiply anything together we want. Let's take care of the numbers first. What would 6 times negative 7 be? Positive times a negative is a negative 42. And then we still have this x times y, so guess what that becomes? Just x times y, or xy. So that took care of our distributive property, multiplying that 6x by everything in the parentheses. Now, when the parentheses end, my distributive property ends. So I don't have to multiply 6x by anything else here because they weren't in parentheses. So these guys really were just hanging out. Now we're going to bring them down because we didn't have to do anything with them yet. Just going to copy them down. Now I'm going to look to see, can I combine some like terms? Is there anything to combine? X squared, do I have any other x squareds? Nope. XY, do I have any other xy's? Nope. Y's, x's. Can I put this y and x together and add them together to create an xy? No, because you can't add two variables that are different. They're not like terms. So this is actually as simple as it gets. And I could change around the order any way I want to because I could use the commutative property. But these four terms are as simple as we can make it. So it doesn't look that much shorter this time than the original one, but it is simplified because what did we get rid of? Those parentheses are gone now. All right, so you're going to do some practice on your own to master this distributive property now.